Okay, so I realized with one tweak, I could almost turn my title into valid Python. A couple things I want to address at the beginning in putting the talk together. I've tried to keep in mind both the remote audiences on Twitter and the folks who are here in this room. That means there are some text slides that here I'm largely going to skip over in the interest of showing you some of the toys I've been playing with for the last several months. So I just want to give you a heads up that when I start zipping through the slides, don't panic. There's no test at the end. I'd like to put my acknowledgements first because it's students like this who are roughly arranged in order from closest to graduation to farthest from graduation, who motivate what I'm going to be talking to you about, which is finding a way to bridge the gap between the high quality software that's developed in open source projects and novice astronomers who don't know how to code it all yet. Little bit of context. In an undergraduate-only program, we get a few new students a year. Half a student per year roughly goes to graduate school somewhere in physics or astronomy. Most of them don't go on. And so my primary responsibility day-to-day is teaching. And we, department-wide, are focused on preparing students for a career afterwards. And I'm fortunate to be in a place where 4 or 5 years ago, we decided to start introducing Python the very first year. And so independent of whatever I'm doing, the students are learning a little bit of Python. There are some constraints. Many of my students use Windows. The solution to that, I think, is the Anaconda Python distribution. As Steve, I think, mentioned earlier, there is an astropy content channel that I maintain. I would be interested in starting an astronomy content channel this week. If you have a package that's not an affiliated package and you want to get it built, all I need from you is what version number you want built, and we'll have to set up a content channel for you, and there's nothing else hopefully nothing else you'll need to do on your end. I wish I could do that, but I can't. So what I'm going to show you is primarily ways I'm trying to come up with of getting students hands-on code and hands-on astronomy as early as I can in their time at our university. Couple of other constraints, because the first question you'll probably ask when you see some of what I'm showing you is why bother? There are packages that do much of what I need to do. The ones that are good for students, though, are typically GUI-based. They don't leave behind much of a record of what the student has done. I don't expect the students to be any more conscientious than I am about actually writing down everything that they do. So what I primarily settled on is using Jupyter notebooks to present the code to them, because I can save the notebook and we've both got a record then of what happened. Somebody earlier, I don't remember, might have been Mario, mentioned the bus problem with software packages, where there's one developer and if a bus comes along, you're out of luck. I prefer to think of it these days as the lottery problem or the Google problem, right? If that same developer wins the lottery or gets hired by Google, you're out of luck. So when I'm looking at what packages to use, I try to look for things that seem to be active, have a bunch of people involved. Well, and that's in part because my favorite way to solve a coding problem is to find out somebody else has done it and import that thing. I'm going to skip this because we'll be coming back to it. And the particular thing I'm going to talk about today is looking for new variable stars in fields that contain known exoplanets. To put what I do in a science context, we have a small 16-inch telescope that the university owns. And so if I had to summarize my science interest, it boils down to if it changes in brightness over the course of roughly an evening, I'm interested. So some students want to look at exoplanet transits. One student wants to look at asteroids. There's other students who want to look at supernovae. The upside of having a small telescope of your own is that the process for applying for time goes like this. Hey, can I use the telescope? Sure. And there's some days even where it's like, it's clear, let's go to the telescope. What are we going to observe now? So one of the ways that I've worked on this last semester of trying to get students involved right away with at least reviewing the data was putting together some scripts that for a night of data would generate a set of web pages with zoomable pictures of the images. The motivation in part is to have somebody look through and find things like that. I don't know. The other reason for taking this kind of approach, honestly, is that the software also creates an issue on GitHub for each night, and there's a link they can click to edit the README for that night, where they summarize what they saw in those images. So behind the scenes, this is in principle a way for me to get them with a GitHub account. They get used to the idea that they can edit things on GitHub. They don't have a problem with using a new website. They're used to that. If I try starting with Git, it hurts. Everybody feels pain. I should be upfront. In practice, this hasn't worked out as well as I thought it would, but I've got some time after this conference. Right, so we will get students occasionally who come in their first week to orientation. We invite them to get involved in our email list for the observatory, and they're out observing in the first 2 weeks of their classes, taking some data. The next piece I want to talk about just for a couple minutes is CCDproc. I'm one of the co-lead developers of CCDproc. We made our 1.0 release last week. What we really need now is people to try it out, kick the tires, find the mistakes, and help us fix them. I wanted to point out one little piece that's new that is, I think, particularly useful. We added an object to represent a directory of images. That object has some iterators. You can iterate over the data, over the HDU, over the header, whatever you want. Filtering by fits keywords. Before SciPy this past summer, I was giving a talk that it's to non-astronomers. I wanted an image that had a nice bright sky background so I could talk about flat fielding and dark current and all of that. The night before the talk, I know in the 30 nights of data that are on my disk, there is one of those images. So I just made a list of the directories, image file collection for each, find all of the light images where the mean's bigger than 4,000, print out its file name, bam. One of the most gratifying things about working on CCDproc has been this. It is, if you're just getting involved in open source, it's maybe a little bit scary at first. You're worried about putting your contribution out there. Once you're sitting on the other side, if someone's actually made a pull request on your package, you're thrilled. It's wonderful news. There are 1, 2, 3, 4 of our undergraduates who have made some contributions on CCDproc or other projects. I typically have them start on some small tractable issue and go from there. Okay, so CCDproc is nice, but I want to do this with undergraduates, and so I'm going to show you a short animation of a notebook or a package that provides Jupyter notebooks with interactive widgets. On the front end, I'm using Jupyter widgets that you'll see in a moment to drive the interactions. On the back side, it's using CCDproc. The students are getting used to executing Python code in a notebook without even thinking about it. I just tell them to hit Shift-Enter. And I've just got a couple of the things in here that I've highlighted. So there's an image browser with browsing hierarchy here based on fit keywords, and then image display and header display. When they get to the point of doing data reduction, there's a set of widgets where they can set all of the, there's way less to this than it looks like, actually. So they click through, they set their settings, the settings get printed into the notebook, so 3 months later we can look and see what they did. The stuff that you do for bias, you do for all of the rest of the images, so I'm going to skip that. One of the things I'd like to work on this week is adding a couple of extra widgets for doing things like making sky flats, which is really just combining without shifting, and for combining images based on WCS. Yep.
If the CCDproc calling structure changed, would the widgets automatically update?
No.
Okay.
Which is why I'm happy to be working on both, because I can prevent, yeah. So, which is not to say that I wouldn't make a change to CCDproc just because Reducer used it, but This past fall, we had a new student who wanted to, as a project in her first semester, make a nice picture she could show her family. So we went out a couple of nights, got some data, pictures of a galaxy. She used Reducer to reduce them and put this picture together. It's not going to win any awards for beauty. In the sense of being a nicely polished picture. And if you look closely, you can see we've got some light leak problems, or there are these blue waves in the sky. It also turns out that when much of the continental US is dry and there are fires, it's redder than normal. But what was fun is that by the end of her first semester, she's used Reducer to reduce some data. She's combined the data to make images in 3 different filters and then put those together. So if I want to do variable star astronomy, data reduction is just the first step. Then I need to do photometry. Right now I'm using a Java program called Astro16, which in many ways is very, very nice. There's a well thought out GUI, it does fitting, it does a whole bunch of things, but it doesn't leave behind much of a record. And there are so many user interface elements that I find it a little bit confusing. But if you're looking for something that is an easy install, you want to use for a short project with a group of students, you're not going to have a lot of time to train, good way to go. I'm going to pretend that I did the rest of the talk this way to make everybody, even the people newest to Python, feel at comfort. In fact, we've been frantically scrambling over about the past 3 or 4 months to get some of this Astro16 stuff working in Python. So don't think you're actually going to get to see it because I flipped right by it. There's a global statement in Python, it turns out. I used it, you shouldn't do that. So what we've been working on is using a couple of different photometry routines, SEP and utils, to do source detection. I wired it up with some widgets yesterday, so you select the source detection routine you want, you wait a few seconds, yes, and circles appear. I'm not responsible for much, but those 2 students have done most of the work behind the scenes on connecting these together, and bam, the photometry's done. If you heard cackling yesterday in the vicinity of the College Inn, that was when that worked. I was up in the lobby, I was laughing out loud, I was so happy. This will have, I think, with a nice widget interface within a couple months. Once you have a bunch of instrumental magnitudes, you need to do something with them. We do differential photometry, so you're taking the difference of the instrumental magnitudes to remove atmospheric effects. It's better to do that with many comparison stars rather than just your target star, whatever it is, and a single comparison. I need help. For me, this is a great opportunity to connect with people who know the science far better than I will ever know the science. I know several different ways of approaching ensemble differential photometry. I have no idea which way is the right way. If you know, please let's get together. And if you know of Python implementations that already do this, that's even better. But for now, right, the students don't want to sit around and wait to do anything, to do science until we do some coding. So, there's this, so that's 2-minute warning?
That's 13 minutes of gone by.
Okay, so, there's this expression in programming that the problems between the keyboard and chair, in this case, I figured the solutions between the keyboard and the chair. If I showed the students a little bit about how to modify Python in a notebook, then we could go back and forth iteratively on putting together a tool that allows them to see what's changing in their field of view. I left that in there just to show how that back and forth actually looks. It's nothing sophisticated. They tell me what they want. I go and try to change that, and then try to recruit them to take huge blocks of code like this and make them easier to use. So what they get is a list where each row is 1 star, each column is a different night of data. The size of the red dots proportional to the apparent magnitude of the star, with trend lines added on there to make it easier to see patterns. Jake and a couple other people developed Gatsby a couple months ago. It's a very fast period finding algorithm. And so the little bars over on the right there says all nights of data plotted. The height of the bar is the Lomscargo power. The higher that is, the more periodicity there is in the signal. I checked the numbers yesterday for one star. It's doing 50,000 trial periods. In this case, it does that 20 times, and it takes about 4 seconds. And so we went, in the last couple of weeks, from struggling with how do you figure out which ones are variable and which ones are not variable, Lomscargo is slow, to just add it on. So again, there wasn't a graphical interface there yet. It will come. But at first, it's easier just to develop the code in Notebook. So I'm going to pick out one of those variables. And this is running, in the other GIFs, I've tightened up the timing a little bit. In this one, I let it run real time so that you could see that the period finding here is just crazy fast. It's going to loop back around again. You may have missed it, in addition to doing the initial power spectrum, it also finds the 10 best periods in a particular range, and then I just plot up. Well, I think you saw it before. Plot up a bunch of those trial periods. And again, this was perfect. I felt kind of silly because I was thinking to myself, I've got to write a little program that will find the 10 best periods. But then I actually read the documentation, and I was like, that already exists. Woohoo! And I'll end with some stuff I've been playing with. The last few days, I'm getting an image viewer to work in the Notebook. So, a few things I'm doing. I've got an image I read in from disk. I find the center, RA-dec of the center of that. I query the variable star index from the American Association of Variable Star Observers. I query a catalog called APAS, the small sky catalog, a few million stars with a goal of getting down to a hundredth of magnitude, roughly, in precision on the magnitudes. The VSX stars are overlaid in blue with the name. What I'd like to do is turn this into a widget-driven thing, so you can specify a table, specify a column you want to label by, and it works. Jake probably recognizes this as MPLD3. And so one funny thing, so this is maybe the opposite of big data, right? This is small data. Interesting thing, so this is the first image I tried this on. And first thing I do to check it is say, okay, are there stars in the circles? And there's this one up here where I'm like, oh, what did I do wrong? There's no star in that circle. Doesn't matter how much I zoom in, there is no star there. So I go back up and I check the catalog because I've got that cell a couple rows above. That's supposed to be a 12th magnitude star. On the bright end, it's supposed to be a 14th magnitude star on the dim end. Those we should be able to see easily. It is a M6 giant, so it's a fairly cool star. It turns out that magnitude, the maximum magnitudes are in the I band. This is an R band image. Maybe that's the difference, or maybe it's more variable than people think. I don't know. So this week, I want to make toys look prettier. I'd really like to talk to people about differential photometry. And again, the ideal solution here is this already exists, and I just have to import the right package. That would be awesome. I will have some things I'd like to get updated in Reducer, which is the notebook that I showed you at the beginning for data reduction. The experimental stuff towards the end is in this repository on GitHub. I was sitting with the students who wanted to work on the software side of things, and we needed a name for the repository, and GitHub suggested glowing waffles. And I was like, what the heck, we'll just be glowing waffles. And a few weeks ago, when I said, we may need to change that so it's a little more professional, they were like, no, we are glowing waffles. So, okay.
Sci-fi theme.
Yeah. Well, I did notice a tweet this morning, PyAstro16 tweet about waffles, and so rather than having a summary slide, what I've got is a list of a bunch of links. I've also dropped this into the Google Doc. I tried to capture, shoot. I didn't get all of the packages that are mentioned in here in this. I left out AstroQuery, I'm sorry. Questions?
have time for one or two.
So you showed me in there PLD3 image viewer, but earlier you were showing NBAG. Is there any, do you have any preference for using one or the other? Are you really trying to have this be independent? I just might say that NBAG is like a regular Python terminal that
Sure.
in
Yep.
the
Yep.
browser, as NPLD3 can exist sort of independently.
So what I would love to have is an image viewer, and in the end, I don't care that much whether it's MPLD3 or whether it's NBAG, but something where I can use a widget to drive it, and that's fairly easy, it turns out. And I want to be able to click on the image and get that mouse click back into Python. That probably the best bet in the long run is going to be BQplot, which is a newish plotting package that uses D3 on the back end, or on the JavaScript side, but is built on the Python side as on IPyWidgets from the beginning. But right now, I'd say there's not a great solution for two-way communication between an IPyWidget and an image.
Okay, but the NBAG one can't communicate with Matplotlib.
Right, yeah, so that one can, and I didn't show it in here. I have this silly example where I click a checkbox and it makes the color of a line change, and I click on the graph and it checks the checkbox. The problem right now with NBAG is that you can't embed it within a widget. It displays in the output area of the cell as opposed to the widget area. There is work underway to try to fix that.
Have you played with bokeh at all for that sort of interaction?
Not much, no. But I was talking to somebody last night who knows about bokeh, who I'm going to hit up later this week for more knowledge.
All right, let's thank Matt again.